Okay, so we are going to continue on with our first lesson here about polars. Now, with polars, we can change them from polar to rectangular. So remember, rectangular is what we've always learned, x comma y, and polars we write in r comma theta. So if we want to convert between the forms, we need some formulas. So let's remember, this is something we learned at the very beginning of the year, that cosine of theta is equal to x over r, right? If we're talking about the unit circle, r is just 1, which is why cosine is equal to just x. But if we're talking about anything outside of the unit circle, then we're talking about r. Okay, well, if I wanted to get x by itself here, I could multiply by r on each side, and I would have x equals r cosine of theta. So that's our first formula. And then the same thing goes with sine. We learned at the beginning of the year that sine is equal to y over r. So if I wanted to get y by itself, I would multiply by r on each side, and I get the formula y equals r sine of theta. Okay, so these are really important. There are formulas. Yes, you have to have them memorized. It shouldn't be that hard to memorize them. X has always gone with cosine, y has always gone with sine. Okay, so if we want to convert the forms, so we've got the ordered pair k, which is at 4, 180 degrees. So that means that r is 4, and that theta is 180 degrees. And we want to find what is x and what is y. Okay, that's what our final answer is going to look like, x and y. Well, we know by our formula that x is equal to r cosine of theta. So x is equal to r cosine of theta. And in that formula, we know r is 4, and we know theta is 180. Okay, well, this is just unit circle. Cosine of 180 degrees is -1. Okay, can never forget about our unit circle. We're going to use it all year. So 4 times -1 gives us -4. So x in our ordered pair here is -4. Now we're going to do the same thing with y. Y is equal to r sine of theta. Well, we know r is 4, and we know theta is 180 degrees. Now sine of 180 is 0, and 4 times 0 is just 0. So our ordered pair, our answer is -4, 0. Now let's think about if that makes sense. If I told you to plot the ordered pair for 180, we would go to where 180 is, which would be right here, and we would go out 4 circles. 1, 2, 3, 4 circles, and that would be our ordered pair. Okay, well, does that make sense that the rectangular ordered pair would be -4, 0? Well, if I want -4 up or down 0, that would give me the same point. So that does make a lot of sense. Okay, so then number 2, w is 3, 5 pi over 6. So once again, r is 3, theta is 5 pi over 6, and I want to find x and y. So x is equal to r cosine of theta. Okay, so cosine of 5 pi over 6. Well, over 6 is a 30-degree angle, so that means cosine is √3 over 2. And 5 pi over 6 is in quadrant 1, so that would be negative. Well, remember, this is just like over 1, so we've got 3 times -√3 over 2, 3 times -√3, which would be -3√3, and then 2 times 1, which gives us 2. This cannot simplify, so that is our x. Y is our sine theta. Sine of 5 pi over 6 is +1/2. Once again, remember 3 could be 3 over 1, 3 times 1, 2 times 1. And then we should always write our answer as an ordered pair. Who will take off if you do not write it as an ordered pair. Okay, so let's once again make sure that makes sense. If we're at 3, 5 pi over 6, well, 5 pi over 6, like we said, is over here, and that's out 3 circles. So does it make sense that if we went -3 root 3 over 2, comma, positive 3 over 2, would we be in the same quadrant? Well, this would be negative, then up, so left, then up. That does make sense to the problem. Okay, now let's go the other way. If we are given, okay, a rectangular coordinate and we want it to be a polar coordinate, our formulas have to change. Okay, so to find r, we're going to do the square root of x squared plus y squared. That should not look different. We've been using that same formula all semester. Okay, we've also, one of them that we know is theta equals tangent inverse of y over x. Okay, so we don't want to use like sine inverse, let's say, because sine inverse would be y over r. And we don't want to use r, we want to use x and y. So the only one that uses x and y is tangent. Now we have to be careful, because if you remember, tangent inverse is only going to answer between here and here. But there's going to be times that we're in this quadrant and this quadrant. So every once in a while, if I get an answer that's here, I'm going to have to move it over here, and the way we move it is by adding pi. Okay, so you're going to have to be outsmarting your calculator here to make sure that you're in the right quadrant. Okay, so for example, our first example here, we've got 7 comma -2. So x is 7 and y is -2. And I want to find r comma theta. Okay, so that's opposite. In this problem, we were given r and theta and we were finding x and y. In this problem, we're given x and y. So if I want to find r, our formula for r is the square root of x squared plus y squared. Now remember that whenever we square a negative, it becomes positive. Don't be that person that messes that up. If that confuses you, sometimes I don't even write the negative here so that it doesn't confuse anybody. Okay, so 7 squared, 49, 2 squared, 4. So square root of 53. And then ask yourself, can that break down? 53 cannot break down, so we'll just leave that as root 53. Okay, so for tangent, or for theta, we'll use tangent. So tangent inverse of y over x. Now ask yourself, can I do this without using my calculator, right? Is 2 over 7 on the unit circle? 2 over 7 is not on the unit circle, so I'm going to have to use my calculator here. Okay, let's make sure that we're in degree mode. So we've got tangent inverse of -2 over 7 gives us -15.945 degrees. Okay, but let's make sure that makes sense. 7 comma -2. So if we went 7 and then -2, we would be down here. Does that make sense, -15? Well, -15 would be in quadrant 4, so that does make sense. So we could use that. However, we always like to have our answers be positive. So if I want to stay in this quadrant, but I want the positive angle, I'm going to add 360. Okay, so we've got root 53, comma 344.055 degrees. Now, technically speaking, this is also the correct answer. Right, it's just one's in a positive angle, one's in a negative angle, just like we were talking about on the last page, right? We can write these in a million different ways. Okay, I could make this a negative root 53, and then we would have to change these angles to the other side, to the other quadrant. Okay, so both of these are correct. Just make sure in Math Excel you're paying attention to if it's okay if you have a negative angle. If it specifically says in the directions that angles need to be positive, then that's how you're going to get your positive angle. If the directions do not specify, then you're welcome to answer with this angle. Okay. All right, -4, -4. So x is -4, y is -4. I want to find r. So 4 squared plus 4 squared. Gives us 16 and 16, which is root 32. Now root 32 can break down. It can break down into 16 and 2, which makes 4 root 2. Okay, now theta is tangent inverse of -4 over -4. Well, that just makes 1, positive 1. So tangent inverse of positive 1 is at 45 degrees, or pi over 4. Okay, right? Because root 2 over 2 divided by root 2 over 2 would give us 1. So we have to ask ourselves, does that make sense to answer at 45 degrees? Well, -4, -4. -4, -4 would be in this quadrant, and 45 degrees is right here. So it does not make sense to answer this in 45 degrees, so we're going to have to add 180 degrees to get from this quadrant to this quadrant. So if I add 180 to 45, we get 225, or because we know our unit circle, we know that that would be 5 pi over 4. Once again, I don't really care if you answer in degrees or radians. Okay, both of these are technically correct. It does not matter to me which one you do. However, you have to make sure in MathXL it's going to specify if you have to answer in degrees or radians. So just follow what MathXL says. So we have 4 root 2, comma 225 degrees. And these are the formulas that we have to remember.